Let R be the region in the first quadrant bounded by the graphs of x to the 1 over 5 and x to the 2. Now you might be looking at that and thinking, what am I looking at here? This is 3D. I'm only used to 2D. Well, here's your x-axis, here's your y-axis, and I bet you know how to graph x to the 2. It would look like this, right? And you might be like, well, no, it don't look like that. It's also going to have another branch on that side. It don't matter. Not for this problem. Now, x to the 1 over 5, how that graph? Just like this right here. That's how it graphs. Now, they're going to intersect at this point right here. Turns out that's going to happen at 1. They kind of helping you out right here with that 1. Then it says region R is the base of a solid whose cross section's perpendicular to the x-axis or square. What the hell are they talking about? Well, they saying that region R is this whole region down here. It's the shaded region. They could have just said that, but they didn't. That's region R right there. But they saying it's the base of a solid whose cross sections perpendicular to the x-axis are squares. So they talking about a solid. Well, where's the solid? It's right here. It's this 3D thing. That's the solid. And region R is just the base. It's just the part at the bottom. And what the hell are they talking about with this whole cross sections perpendicular x-axis or squares? Well, I'll tell you, this right here is a cross section of that 3D solid. It's a 2D surface. It's what you would see if you came on in with a big old knife and you done cut it right here. You would see a shape that looks like a square. And that square is perpendicular to the x-axis. Right here, you got yourself something that would be perpendicular to the x-axis. If y'all draw that right through here, get yourself a right angle. So that square is perpendicular. So they done did you a favor here and they drew it so you didn't have to. Now if I come on through here and I draw myself another square right next to this one, then it would have a little bit of thickness to it. And it might look like a DVD case. And that itself would have a little thickness to it. A little thickness we're going to call dx. And what you do when you're trying to get a volume of any sort of solid, turns out you take the integral of the area of the cross section formula and multiply that by dx. Now we need ourselves some boundaries here. From 0 to 1. So the real question is, how am I going to get myself a formula for the area that's based on x? Well, I'll tell you how. You gonna remember you got yourself a square. So once you get the length of this side right here, you're just going to multiply it by itself because this one's going to be the same. So it's going to be something squared. In fact, that's why it's called squared. Bet y'all never thought about that. But what we're going to put in them parentheses is the length from this here point that's at an x coordinate I could just call x but it's got a y coordinate. And remember, that one was the one I put in blue before? That one was the x to the 1/5. So that's this y coordinate right there. Now down here at this other done point right here, you got yourself an x, and by the same logic, you got yourself an x squared. Now this might not be looking too comfortable since we're all 3D and whatnot, but turns out this right here would be a vertical line. And the way you get the distance of a vertical line when the x coordinates is the same is you just done subtract the y coordinates. So you got to just done subtract x to the 1/5 and then done subtract x to the 2, and then you got to done take the integral of all that, and you just got to slap one of them dx's on the end of it, and you'll get your answer. Now, the rest of this problem is for babies, but I know most of my viewers here pretty much fit that description. So we just gonna wrap this up with a plus b squared. Just put that integral in a form for taking the reverse power rule, and holy moly, that's gonna be 10/5 plus 1/5. And I forgot the minus sign here. And no, I ain't gonna cover how I'm doing this part. If you don't know this part, then too bad. Okay. And I'm actually not even gonna finish the problem. I don't even care. Don't forget to subscribe.